Hello, in this video we're going to go over a one-tailed test, and this would be for the teacher-led and student-led examples. So please have that handout handy and follow along for the teacher-led example, then pause the video for the student-led example and watch to see if you had done it correctly. You also might have noticed that I did not have a video for the student-led effect size for Cohen's d, r-squared, and confidence intervals. We will go over that in the Zoom session. So now again, we're moving from a two-tailed test to a one-tailed test, and this is just an example of what that would look like. Here, the hypothesis will be saying that the new scores will be lower because we're down here in this one-tailed region than the population mean. If we wanted to say it was higher, we would be in this tail. So, but it's a one-tailed test, so our critical T will be different. So here's our teacher-led example. This is the same example from earlier on, so it makes it a little bit easier. We don't have to do a whole bunch of calculations. So the thing that we need to pull out is, what is our hypothesis? We need to talk about, because that's going to be different than our hypothesis for our two-tailed test. So we see here that our significance level is 5% and that the scores are greater than. So if we want to talk about our hypothesis, we have our null and our alternative hypothesis. And I always like, for the one-tailed test especially, to start with our alternative hypothesis. So here we're saying that the mean of the treated group is greater than the population mean, which is 6. And here we'll say that the mean of the treated group is everything else, is less than or equal to that population mean. And then next what we need to get is, we already have our calculated T, and I'll write that in a few minutes on the slide because we did the calculations earlier. So we don't need to take all these values and get our x and our x squared, our sum of squared deviations, because we did this previously. If you're curious about how to do that or you want a refresher, go back and watch the earlier hypothesis testing, because the calculations are exactly the same for the one and the two-tailed test. The thing that differs is the hypothesis and our critical region. So we need to look and see, we have a sample of 1, 2, 3, 4, 5, 6, 7, 8. So we have an n of 8, which means our degrees of freedom, remember, are n minus 1, which means it's 8 minus 1, which means there's 7. So we need that information. We need the 5% significance level and our degrees of freedom to go to our table. So here we're at the T distribution table, and we're doing a one-tailed test with a 5% significance level, which equals 0.05. We said our degrees of freedom was 7. So we're going to go down to this row here where degrees of freedom are 7. And we're going to come over here to this column, and this gives us our critical T of 1.895. So now here we are back at our example, and we said that our critical T was 1.895, and then our calculated T, again, we calculated this earlier in a previous video, our calculated T was 2.54. So now we need to make a decision. So here again, we're looking at values that are greater than the population mean. So it's going to be on this side of the distribution. We have our 1.895, and we need to decide, where does this 2.54 fall? Is it in this part where our null hypothesis is correct, or is it out here in the critical region? And 2.54 is probably going to be way out here. So it's definitely in our critical region, so we reject the null hypothesis. So we can say that after the experimental procedure, the mean of the tested population or treated population was significantly greater than the mean of the general population. All right, now for our student-led example. So here, again, we need to pull out a few things. We need to look at our sample size was n, so that means our degrees of freedom So if our sample size is 9, degrees of freedom are going to be 8. We have a 5% significance level again, which gives us a 0.05 probability that we're looking for in the table. And then we need to do our hypothesis. So here, it's saying the scores are lower. So for this one, our alternative hypothesis would be the mean of the group using the ebooks has significantly lower scores than our population mean. And our alternative hypothesis would say that the mean of the group using the ebooks had scores greater than or equal to the population mean, so everything else. Now we're going to go ahead and find our critical t from the table. So here we are at our t distribution table again. We said we're looking at proportions in one tail, and we said we had a 0.05 significance level, so we're in this column here. We also said that our degrees of freedom were 8. So if we come over here, this gives us a critical t of 1.86. So now we're back here at our example, and we said that our critical t equaled 1.86. And our calculated t, and again, we don't have to do those calculations because we did it previously. So if you want a refresher of how to get the calculated t, please go back and rewatch the student-led hypothesis test example for a two-tailed test. And that value is negative 2.37. So let's look at our distribution. So we said with our hypothesis, we also need to add our critical t is going to be a negative 1.86, right? So our boundary is here, 1.860. And we need to know, because we said that we hypothesized that our scores would be significantly lower. So does this 2.37 fall in the areas where we would fail to reject the null hypothesis, or out here in the critical region where we reject the null hypothesis? 2.37, way out here again. So again, we're going to reject the null. And you can say that students that use the ebooks had significantly lower test scores than the rest of the class.